So this time the very important type is now my screen is sharing with you. So I'm sure that you can see now. Are you
Yep.
looking?
Yep. Linear
Okay.
function. Yeah.
Linear function, types of function, we'll talk about that. So first we will define that and we'll talk about the properties. And in the later stage, we'll talk about one-to-one function also. Now let's see. So this is the topic and now let's see. The next is, so once again, this is the introduction of linear function and we will talk about the definition and at the later stage, some properties. So linear function is, if you can read, please read
Sure.
this. Yes.
Yeah. The linear function is popular in economics. It is attractive because it is attractive because it is simple and easy to handle mathematically and has many important applications. Linear functions are those whose graph is a straight line. A linear function has the following form: y equals uh, fx is equal to a plus b, and
Yes.
then a linear function has one dependent variable and one independent variable. The independent variable is x and the dependent variable is y. A is a constant term or the y-intercept. It is the value of the dependent variable when x is equal to 0. B is the coefficient of the independent variable. It is also known as the slope and gives the rate of change uh, of the dependent variable.
Okay. So actually this is the, what we can say, the general format out there, and that is representing a straight line. So y is the depending variable, x is independent. Here we can find the intercepts on the x-axis and y-axis. So we can say that this is f of the x. So this is the most general or standardized format of the linear function. Now the next is, so following graph shows linear function. So positive slope. Actually, when we have a straight line, so all about that is the position. Either it is increasing or decreasing or whatsoever is the position on with respect to the horizon and the vertical line. That is the Cartesian plane. So when the line is tilting and that is going upward and tilted towards right, then we can say that it has having a positive slope, the gradient. So next is the negative slope. Once again, the same thing. A straight line, a linear function is representing this straight line. And here we can see the negative slope because it is tilting towards left. So that's why it is a negative slope. So sometimes we have the horizontal lines. So their slopes are horizontal, their slopes are horizontal, what I mean to say, parallel to x-axis. So they don't have any slope. So that's why horizontal slope is always 0. So in this way, we can say the line passing through this. So we should say their gradients or their slopes or inclination is 0 and they are parallel to the horizontal line. Here, horizontal axis is the x-axis and the vertical axis is y-axis. Next is, now you can see a lot of functions are given and sometimes only the graphs are given as we can see here. And we are asked just to find the types of the functions. So if the
Right.
graph, whatsoever the position of a line is given, if that line is straight, just like a straight line, whatsoever the position is. So irrespective of their position, if the function is representing only a straight line, then clearly we must say that each and every line in the graph representing a linear function. On the other hand, we can see all these lines, these are not straight lines. So that's why
Yeah.
these are non-linear functions. So
Right.
positions are different, but the one thing is that they are zigzag. There is no straightness. These are not the straight lines. So we should say these are non-linear function. whenever we will see these type of the graphs, so immediately we'll have to say that these are nonlinear and these are the linear functions. So properties of linear functions. So a lot of time we are given so many graphs, so many pictures, diagrams, and sometimes we are asked to find about some what we can say those properties. So sometimes they are asking about the intercept, sometimes they are asking about the slope, and then they are just asking just to write down the equation of the given graph. So that's why it's very important to know each and everything about the linear function. So we are starting from here that the intercept, the first is the intercepts. So intercepts are basically where those straight lines are intersecting x-axis and y-axis are both or any one of the axes. So the y-intercept, there are two types of the intercept. One is x-intercept, the second one is y-intercept. So the y-intercept of a function is the value of y when x is equal to 0. So at that time, if the function is given, if the equation is given, if the graph is given, and you are asked to find the y-intercept, simple, the mathematical trick is just to put the value of x in the equation of the function.
Right.
Then whatsoever you will get, that will be the value of y, and that is called the y-intercept. So it's a thumb rule. When you are asked to find the y-intercept, just put x is equal to 0. You will get the y-intercept. So in this way, we can say, looking for the y-intercept, put x is equal to 0. Similarly, where the graph crosses, and in this way, we will find that point where the line is intercepting the x-axis, or what we can say, that is the point. And when we are looking for the x-intercept, so the same thing, but this time we are putting y is equal to 0. Whatsoever the y is given, we are just putting that value, each and every y is being replaced with 0. So in that way, we'll get the x-intercept, where the graph crosses the x-axis. So for the y-intercept, it will intercept the y-axis, and x-axis will intercept the x-axis, the x-intercept will crosses the x-axis or intercept or meet the x-axis at that point where y is 0. And at that point, that is called the point of interception, or we can say that here, this point or this value is the x-intercept. So I'm sure that each and everything is clear about
Yep,
the intercept.
sounds good to me.
So a lot of questions were there over when you are asked to find the intercepts, the lines and the graphs are given, and so many type of the graphs, and you are just looking for the intercepts. So by looking, if the equation is not given, only the graph is displayed. So from that graph, you can just locate if this graph is given on the scaled graph paper, then you will have to count all these for the y-intercept, and this point how much is at going above or below the y-axis. And if you are looking for the x-intercept, so you will have to count all those scales, all those squares, that how much it is going away from 0 on the on the x-axis. So in this way, without the equation, you can just pinpoint the y-intercept as well as the x-intercept. Isn't that?
Yep.
Yes. Okay. So the other thing is that if you are just looking for the slope and only the coordinates points are given, no graph, no equation, but at least 2 points are given from where those lines, the linear graphs or the linear equation will pass through. So slope is, or the gradient is simply the rise over run. This is the ratio between the rise and the run, that how much the line is rising. and how much it is running towards left or right along the x-axis. So at that ratio, to find that ratio, if the 2 points are given, then this is the golden rule that y2 minus y1 over x2 minus x1. And you can change the order, but only the one thing is that is the most important is that if you are changing the order in the numerator, so that order must be followed in the denominator also. So from
Right.
here you can see that if you are putting y2 as a first and you are subtracting y1 from y2, so that should also be done in the denominator because this is x2 minus x1. So x1 must be subtracted. If you are going on the other way, so that must be of the same rule that if you are putting the first point and then the second, so that must be with the abscissa or the x coordinate also. So only care is this one. Otherwise, the order doesn't matter, but that should be maintained for both the numerator, for both the rise and for the run also. So in this way, if the 2 points are given and you are looking for the gradient or the slope of that line, that graph, that equation, then you will have to do this trick and immediately you will get the exact value of the slope, which is actually the ratio. That's why there is no unit of slope. So
Right.
slope intercept form. So next is that sometime the lines are given and they are representing some what we can say the graphical mode is over there and you are looking for you are asked to find out or recognize those lines. So if the line is matching with this format, so you can say this is the slope intercept form and this is for the straight line, this is for the linear function, this is of any line. So y is equal to mx plus b. So once again, we can say m is the slope or gradient of that line and b is the intercept. So m equals to the slope and b equals to the y-intercept because this is given in the y format. So that should be b is equal to y-intercept. So similarly, if the equation is given in this format that x is equal to my plus a, then a is the x-intercept. So that may be according to the position in the Cartesian plane. So at that time, you can say that either this is the y-intercept form
Right.
or x-intercept form. So slope intercept form is very familiar and the simplest of the linear equation of the linear graph. So next is the horizontal vertical lines. So we have seen sometimes the lines are not tilting, the lines are not inclining to any direction. We are getting the straightforward lines. So if y is constant, that this distance is a constant at a specific height, the line is passing through, the graph is going on. Then the graph is a horizontal straight line. The slope is 0. Example, y is equal to 7. So in this way, the zero slope, because line is horizontal to the x-axis, there is no question of any tilt or any inclination. So in that way, we can say the line is just horizontal to the y-axis. So if y is a constant, so you can write y is equal to 7. Similarly, if x is a constant, then the graph is a vertical line. The slope is undefined. Undefined means that x is equal to 8. Now it's a totally vertical and by all means of that, the inclination is just what we can say right angle at the right angle. So in other way, if you are using the trigonometry, so at that time that is the angle is 90°. So 90°, whatsoever you are looking for that ratio, the rise in the run. So in that way, you will get the division of 0. So in this way, there is no run, only the rise is rise. So in that way, you will get the infinity. What I mean to say that something divided by 0 that will not possible, that is undefined. So that's why its gradient, its slope is 0, is undefined. So if the slope
Right.
is 0, the line is parallel to x-axis. The slope is undefined, the graph is showing just like that, then we can say the straight line is a vertical line. which is perpendicular to x-axis and parallel to y-axis. I'm sure that you are getting this.
Yeah.
Okay, so we are moving to the next. So forms of the linear functions equation. Slope intercept form. So y is equal to mx plus b. M is the equal to the slope and b is the y-intercept, and point slope form. So sometimes the graph is given in this shape and we'll have to locate its equation, mathematical equation. Or in other case, the equations are given and we will have to recognize or we'll have to draw the graph. Then these 2 points, if the 2 points are given, then y minus y1 is equal to m x minus x1. M equal to the slope, x1, y1 is the point on the graph. If only one point and the slope is given, then you will have to use this format. Or if the graph is given in such a way that it is passing through one point and it is also indicating some inclination, or it is
Right.
tilted towards right or left, then at that time we will have to find the m, the slope, and that point is from where the line is passing through. So in that way we will have to get, or we will have to write, or we will have to express that graph in the mathematical or algebraic format, just like that. So ax plus by is equal to c is another form, that is general form. So ax plus by is equal to c. A, b, and c all stand for the constant integers. So these are for the integers x and y. These are varying, and when you are putting the variable x and y, changing the values, you will get different type of the lines. So the only one thing is common about all these, that these equations representing the straight lines. And if you are going to draw that, so you will get the straight lines. And these linear equations are representing the linear functions also, linear functions equations. So if the functions and you are just going to convert them in equations, so you will have to be one of these formats. So let's see. So next part is, that is also very simple one, that is one-to-one function. So one-to-one
Right.
function is very simple. This is just for the reminder, and a lot of equations, lot of graphs are given, where we will have to find out that what is the type and how these are one-to-one. So because there is one-one function, there is bijective function, there is surjective function, injective function. So we will
Right.
have to differentiate between all these. So we'll have to look at the, what we can say, the definitions, their formats, and immediately we'll have to decide that one-to-one function. Then we will be in a better position to understand the inverse function. That was the last topic. So one-to-one, please read this one.
Sure. One-to-one function, a function that is one-to-one if each element in the codomain has a unique pre-image. A function f from a to b is called one-to-one or one-one if whenever f of a is equal to f of b and then a is equal to b, no element of b is the image or of more than one element in element a. In a one-to-one function, given any y, there is only one x that can be paired with the given y. A function is said to be injective if it's one-to-one.
Yes. So the other name is injective. So one-to-one function is also called injective. Injective function one-to-one. So here we have used the codomain. Codomain is actually the range, and the function is one-to-one. That is, the range is for every element of the codomain is an image of some that is in the domain. So function f from a to b, there are two sets, a and b, is called one-to-one, or we can say one-one. If
Right.
whenever the value of fa is equal to fb, that is, a is going to b, no element of b is image of more than one element in a. So that should not be doubling. Just one is going for the one. So if one-to-one function given any y, there is only one x that can be paired with the given. So it's also called injective. Now let's see some examples. So examples are one to one, one function. Look at this. A function is one to one if no more than one element in the domain is paired with an element in the range. So our codomain is also called the range. Note every uppercase number has exactly one lower case letter partner. Look at this. This is going to A is going to small a, B is going to small b, C is going to small c. So one and one. Nothing left over here. Nothing is left over here. No one is getting the double image. So
Right.
one. So simple is 1 to 1 function. So here for a few more examples, you can see a 1 to 1. A 1 to 1 function, look at this. Although the things are slightly different from here, but we can say that A is going to 1, E is going to 4, and I is going to 5, and 0 is going to 2. So although we don't have any engagement of 3, this is not imaging over here. But once again, we can say it's a 1 to 1, 1 to 1, 1 to 1, although he is not in the codomain of this function or range of this function. But because the uniqueness is there, so it's a one-to-one function. On the other hand, look at this. Only difference is that now 0, O is also imaging to this, and E is also imaging to that too. So a function that is not one-to-one, and reason is very much clear. Now, it's a function because as for the easy understanding, we can say that this is the first test set is the set of women and these are the set of men. So women should not be left unmarried or should not have the two relation or two husbands. But a man can have two wives. Look at this. So this two, one is the lucky one having E and also having O. But it is a function, but it is not 1, 1. Oh, 1, 1. This is doubling. So when there is not a unique image, then we can say it's a very easy way just to graph it by visualizing, just making the pair in this way. And if you are getting this type of the thing, you must say this is not 1 to 1. I'm sure that you are getting this.
Yep.
Is there any confusion about 1 to 1?
No, I'm pretty sure I get it.
Okay, absolutely. So another example, look at this. This is 1, 1, and you can see each arrow is going to single, although it is not paired with anyone, but even then,
Right.
even then it is 1 to 1. And here we can say this 2 is once again going to O and H. So this is not 1 to 1 because this 2 is just making the problem that O is going to 2 also. H is, although it is a function, but this is not 1 to 1. And this clearly
Right.
1 to 1, 1 to 1. Each one is engaged only once. So examples of 1 to 1 function. And now you can see these may be of any degree. Fx is equal to x cube. This cubic function possesses the property that each x value has one unique y value that is not used by any other x element. This characteristics is referred to as 1 to 1. So fx x cube, and this is also if you are just plotting this, if you are getting some values, you will get the unique values for each and every fx. And here, once again, you will get the same 1 to 1. So all odd function, these are all odd and all odd function. One thing, last time we were talking about the even and odd functions. I'm sure that that is very much clear to even and odd.
Yeah.
Oh, yes. So every odd function is 1 to 1. So there is a very strange and interesting fact that whenever, if you can decide, if you're asked that whether this function is 1 to 1, so you will have to look that if it is an odd function, then simple answer is straightway. You must say that each and every odd function is 1 to 1 function. So from here, we can make the generalization that whenever the odd function is given, if the function is not even, then it must be 1 to 1. Another way, we can say that each and every odd function is 1 to 1 function. So let's see, the next is examples of functions that are not 1 to 1, not 1 to 1. So fx, the modulus value of x, and fx is equal to x square. And one more is f is equal to 1 over x square. Note that fx
Right.
is equal to x square. This one is not 1 to 1 if it is uh, from the set of integers, negative and as well as non-negative to n. Because for example, f1 is and f minus 1 is 1, because due to the square, the negative value is also becoming the same. So the square of the negative value is the same. So if you are taking plus 2 or minus 2, you will get the 4. So that's why minus 2 and minus 4, they are imaging to what I mean to say 4. So that's why this is not 1 to 1. The other function, the function fx x square from the set of natural numbers n to 1 is a 1 to 1 function. Now in this way, so if they are the natural number, if they are not the integers, because in the natural number, those are the counting numbers. Natural numbers are starting from 1, 2, 3, 4, 5, and so on. So in this way, there is no question of negative. So if this stated that the domain of this function is a natural number, then it will be 1 to 1. If domain is not stated, or if domain is stated just like the integers, so if its domain is integer, so integers can contain negative as well as the positive number. And why this is not the 1 to 1? Because the modulus value also contain negative and positive values. So you can take two values for the modulus, either this is negative x or the positive x. So all the modulus functions are not 1 to 1. All the square functions, all the quadratic functions, if their domain is not mentioned, or if their domain is instead of integers, so you can take the negative values. These are 1 to 1 only when their domain is specific, when they are belonging to the set of natural number, or otherwise stated that for each and every x belongs to a positive integer, then it will be 1 to 1. Otherwise, if you are including the negative number also, so you cannot say about this that this is 1 to 1. And this is the reciprocal of the same. The rules are same for the last example. So now it's your task. If you can take the screenshot, so injective or 1 to 1 function, a function is injective if a1 not equal to a2 implies that fa not equal to fa. So example is 5 is injective, and you will have to verify. Anyhow, so this was what we can say all about the next. We'll talk about the onto function. So we have a time. So a few slides
Right.
for onto function. So that is for the next time. And this is all about that.
Right.
So I will send all these slides to you, and a recap video is also available very soon on Skyhawks Academy YouTube channel. So thank you very much for joining today.
Yep. You're welcome. All right.
Anything you
Rafis.
want to ask?
No, I don't really have any questions. I think that was a pretty good explanation of what.
Okay. One more thing is that for the next week, you must also send few more screenshots where you are facing some problem or anything about the any other topic. But I mean to say, this was all about the graphing the functions, their end behavior, their slopes, intercept, there a lot of things are involved over here. So we are covering this one more or two more lecture about the functions, and I'm sure that each and everything will be crystal clear to you about the graphing, about the functions, their types, their values, and so on. But if you are finding
Right.
any other topic other than the functions, which you are going to read or which you are going to study in your next classes, so you must send also those topics. So we
Okay.
definitely prepare the comprehensive lessons, few lessons for those topics. And after those lessons with me, with all these explanations, you will be in a better position to do your task immediately, and you will be in a better position to understand all those types. So if there are some other topics just like quadratic equation or any topics whatsoever about the matrices, determinants, or whatsoever the syllabus outlines are there, so you can send, and we will take time to make the lesson according to the appropriate level of difficulty. So if you are sending some sample problems also, so that will help us to make the lesson according to the standard of that difficulty level. So I'm
Yeah.
sure that you
Okay.
will send in few days.
Yeah, I will.
Okay, okay. Thank you very much. Allah Hafiz.
All right. Allah Hafiz.